right, today we are doing 7-5. Yes, we are skipping 7-3 and 7-4. We're going to get, those are division strategies that I think are more confusing than they are helpful, and we'll get into more division next chapter. So we're going straight to 7-5, and we're talking about number patterns, also known as input and output tables. If you know what that is, this is going to be easy. If you don't worry. That's what I'm going to teach you. Real quick, I need to do a glasses check. We got glasses there. Going to get some glasses. All right.
I don't need glasses.
Now, we are going to take notes that go with this problem in our book here. So we're going to look at this problem in our book, but then we're going to write notes in our notebook. So I'm going to take a look at this problem real quick. It says there are 2 liters of juice in 1 bottle. How many liters of juice are in 5 bottles? So we can use an input-output table to make our number pattern, okay? We're going to use the rule multiply by 2. The rule tells us to multiply each input number by 2 to find the output number. What does that mean? Well, let's draw a quick table here. Okay, now there are 2 ways you can draw input-output tables, okay? So I'm going to draw 2 different input-output tables. The first way is we can go across like your book draws it, okay? So we're going to have input, which is our number of bottles, and our output, that's our number of liters, okay? And then, hang on. I need...
It's letter 2, 3, 4, 5.
Okay, I'll fix it in just a sec. Alright, I'll fix it in just a second for you. Or I'm fixing it right now. Oh, my bad. I did not fix it.
Don't worry.
You gotta hang on. Okay.
Wait, do you have to pause the video?
I didn't right now. I might in a second. Alright. So, if you remember in our problem, it says there are 2 liters of juice in 1 bottle. Yes? Okay, so we can go ahead and fill this out right now. My input of bottles, let's do 1 bottle, right? How many liters of juice are in 1 bottle, it said?
2.
2. So my input is 1, my output is 2, right? There's 2 liters of juice in 1 bottle. We want to find out how many liters of juice are in how many bottles? Sorry. 5 bottles, right? We want to know how many liters of juice are in 5 bottles. So I'm going to do my input here, and we're just going to go up. So here's 1 bottle, 2 bottles, 3 bottles, 4 bottles, 5 bottles. Okay? And so we can follow our input-output table to get how many are in 5 bottles. So if there's 2 liters of juice in 1 bottle, how many liters of juice are going to be in 2 bottles? Sebastian?
4.
4. Okay? How many liters of juice are going to be in 3 bottles? Isaac?
6.
6.
Yeah.
Yeah. Yes, you may.
Okay.
Alright. So, yes, Isaac said 6. That is correct, okay?
I'm too going.
Now, how many liters would be in 4 bottles, do you think? Angelina?
8.
8. Do you guys notice a pattern here?
Yeah.
Okay. And then Hazel, how many liters would be in 5 bottles? 10, right?
Harrison's on the board.
Okay. You'll notice, in a second, what are our patterns here? Our input goes up by what?
1.
Okay. Our input goes up by 1s, right? What does our output go up by?
2.
up by 2s. Now, is it going to be the same pattern every time we do an input-output table? No, this one goes up by 1s and 2s, but they won't always, okay? But you can draw your input-output table this way, but notice it says our rule, if we remember, it told us to use the rule multiply by 2. What are we multiplying by 2, do you think? What number is being multiplied by 2 in our input-output table?
1.
Our inputs, right? So we put in, so think about it, when I was a kid, we always talked about input-output tables as like a machine, okay? We put in a 1, we do the rule, which is multiply by 2, and out comes a 2, because 1 times 2 is 2. If you put in a 2, you do the rule, you multiply by 2, and out comes a 4, okay? Look at it this way instead, okay? You can also draw an input-output table vertically like this instead of horizontally, okay? It's the same thing. It's up to you. If you think you like this way better, draw it this way. It's up to you if you want to draw it this way or not.
It doesn't matter to me.
Okay? But some people look at it this way better, and I'll tell you why. Okay? Because some people really like to see the visual of multiplying. And if I do it this way, my rule was what again? Multiply by 2. So I can take each of my numbers in my input, and I can literally write times 2 if I want. And sometimes that helps people get the right answer on their output. If you can literally write out times 2 on all of them, it's going to help you get that right answer. Do you see what I'm saying? Because then you easily know what you're multiplying. Let me make it less blurry for you. But now we can go through, and yes, it's going to be the same numbers as before, but we can really see that multiplication. 1 times 2 is?
2.
2. 2 times 2 is?
4.
3 times 2 is? 4 times 2 is?
8.
And 5 times 2 is? 10. So, we got the same numbers. You don't have to write it this way, but if it helps you to see that multiplication across the board like that, then draw your input-output table like this. Okay? There's nothing wrong with that. Okay? The most important part is that you get the right answers. So, truly, you can draw it horizontally or vertically, whichever way you want to draw it. That's not a problem. Okay? If you would like to box it up, you can. But box it quickly, because I'm going to write another little problem here. Now, if you don't want to write the problem, you don't have to, but you are going to want to write the input-output table that we're going to use with this problem. So, we're going to write a problem here. I'm going to write a problem here. It says, use the rule, multiply by 4, and input numbers 5, 7, 9, and 11
5, 7.
to write the pattern of output values.
How many numbers is there? 4.
Gosh, why is it so blurry today? It literally is getting blurry so quick today. It drives me crazy. I just recast it. It's already blurry. I need to get what my G has, because hers doesn't get blurry anymore. I know, because she uses a different
Brand.
No, she has like a USB connector instead of a Bluetooth connector. Or it's a Bluetooth connector instead of the Wi-Fi, and it works better. Which I guess Bluetooth is still connected to Wi-Fi, but I don't know why hers doesn't get blurry. I need to look into what she has. Okay.
No, Strome's TV was getting blurry last year.
No, it wouldn't get blurry. It just turn off.
Oh yeah.
Just stop. And so, Alright, remember when she got her new TV?
Okay, I know, and she hit the old one. Alright, this is the problem we're looking at here. It says, use the rule, multiply by 4, and input numbers 5, 7, 9, and 11 to write the pattern output of the values. So I'm going to first draw myself a table here. And I'm just going to write input and output because we don't have like a word problem to go with it. Yes, we're literally just drawing a table. Okay? And real quick, how many input numbers does it give me?
4.
1, 2, 3, 4, right? So I want to make sure I leave space for 4. 2, 3, 4. For 4 input-output spaces in my table here. I know, I'm about to recast it. Okay, I'll recast it for you. But go ahead and get that written in. Draw your little table. Okay? You don't have to write out the problem if you don't want to, but you do need to write out the input-output table, okay? So, in this case, sometimes you'll have problems like this, where it'll give you the rule and the input numbers, and then you just have to fill out the table. So, let's pay attention first of all. What does it say my rule is? It tells me the rule. You can look up on the board, and if you didn't write the problem down, you can look up at the board. What is my rule for this input-output table? Henry, what's my rule? Okay, my rule is multiply by 4. So I'm also going to write that right here, so I don't forget. Okay, so my rule is multiply by 4, so I want to make sure I'm doing that, right? Then, what are my input numbers? It tells me what numbers to put in the input section. What numbers does it tell me to put there? Sebastian?
5, 7, 9, 11.
Yeah. My input numbers are going to be 5, 7, 9, and 11. It literally tells me those right there. So, I'm going to write 5, 7, 9, and 11 as my input numbers. Now all I have to do is actually find the outputs. I know my input numbers, I know my rule, so all I have to do is find the outputs, okay? I can find the outputs by doing the rule to each of my input numbers, right? So, I'm going to take my first input number 5, and what am I going to do to that 5? Abigail, what am I going to do to that 5? What's my rule, Abigail? So what am I going to do to that 5? I'm going to multiply it by 4. What is 5 times 4? 20, good. That's my first output. I multiplied 5 times 4, and I got 20 as my output. Alright, my next input number was 7. What am I going to do to that 7, Isaac?
Multiply it by 4.
I'm going to multiply it by 4. What is 7 times 4? You know, or you need some help? You have your table? Oh, good. Look at your table real quick.
28.
28, good. Okay. My next input number is 9. What am I going to do to that 9, Reagan? What? Oh. What am I going to do to that 9, Reagan? What's my rule, Reagan? So what am I going to do to that 9? What? What am I going to do? Don't give me the answer yet. What am I going to do to that 9? What'd you say? You're talking so quiet, I can't hear you. Yeah, I'm going to multiply it by 4, right? You got to speak up, though. I can't hear you over there.
I said 9 times 4 is 36.
Okay, and then what is 9 times 4, Reagan? What? Speak up, girl. I can't hear you.
We need to get a little microphone.
Yeah, clearly. Well, I've heard you be louder than that. All right, and then my last input number is 11. What am I going to do to that 11? Angelina? I'm going to multiply by 4. What's 11 times 4?
44.
44, good. Okay, so sometimes you'll have problems like that, where it will give you the rule and the inputs, and you have to find the outputs. But those aren't the only types of problems you'll have. So let's look at a couple more, because sometimes it'll give you some of the inputs and some of the outputs, and it wants you to find the rule. Okay, so let's look at another one here. Okay, I'm going to make it less blurry for you in just a second.
That's not on our worksheet.
Okay, what?
That thing you just said is not on our worksheet.
Might be. Okay, so I'm going to make a little input-output table here. We got 5 spots. 3.
This doesn't really have. This has some stuff to do with division, but it's not all about division.
Correct. Next chapter is when we really get into division.
This is like add, divide, and multiply.
Okay? Sometimes it'll give you, let me make it less blurry while you do this, we get this written in. Sometimes it'll give you a full input-output table. But what it wants you to find is what was the rule. Okay? So it gives you a table, but you have to figure out what's the rule that this table is following. Okay? So, how can we find what this rule is? Well, we need to look at our inputs and our outputs. Okay? So, like, how could we get from 15 to 5, do you think? I want you to think about that for a second. I see someone with their hand up, but I want more of you to come up with it. How could we get from 15 to 5? Hazel, how do you think we get from 15 to 5? What about 10?
9.
Okay, we could subtract 10. 15 minus 10 is 5, right? But remember, the rule has to work for every single option, right?
Yes.
Has to work for every input. So, hang on. 15 minus 10 does equal 5. Okay, that works for this input, but we have to try it on multiple inputs to see. So let's try minus 10 here. What is 12 minus 10? 2. Is that our output here? No, so that one is not the rule. So minus 10 is not the rule, but that was a great guess, okay? She's looking at her information, she's trying something, but now she knows it's not that. What else could it be, Sebastian?
Times 3, divide by 3.
He says divided by 3. 15 divided by 3 is 5, yes?
Yes.
Come in. Or is it our magnet out there? Will you grab it? Thank you.
Come on.
Okay, so 15 divided by 3 is 5. Now let's try it on the next one. What's 12 divided by 3?
4.
4. That does work. What's 9 divided by 3?
3.
It is 3. That works. What's 6 divided by 3? 2. That works. And what's 3 divided by 3?
1.
1. So my rule here is divide by 3. Okay? Now, sometimes they'll give you something even a little trickier than that. Okay? Let me draw another input-output table here. Okay, and here's what the information they're going to give you on this one. They're going to give you all of the inputs.
But none of the outputs.
No, I'll give you some of the outputs.
Oh, then that's
Hang on. And they're not going to tell you the rule. So, you have to figure out the rule, and then once you know the rule, you have to fill out the rest of the outputs. Does that make sense? Okay, so, let me make this less blurry for you real quick. Okay, so looking at this, hang on, less blurry. All right, looking at this, we have all our input numbers. What?
Want me to erase the board?
Sure. Okay? So how do you think we could get from 10 to 7? What's something we could try there as a rule? Emma?
-3.
Emma says -3. Let's try it. Does 10 minus 3 equal 7?
Yeah.
Okay, that works. Okay, let's try it and see if that works for our next one too. So let's see if 12 minus 3, what does that equal?
No.
Does it equal 9?
Yeah.
Yeah, so that works. So if it works for both of these, that means our rule is going to be
-3.
subtract 3. So now that we have our rule, we can fill out the rest of the table, yes? So what's 14 minus 3? 11. What's 16 minus 3? 13. And what's 18 minus 3? 15. Okay? So I knew my rule was subtract 3. And once I figured out my rule, then I could easily fill out the rest of the table. Okay?
I think that's easier than the other one. You don't have to go through all of them. You just have to go through 2.
How are we feeling about this?
Can we get an
Okay. The hardest part, I think, for you guys
Is what?
is going to be
The word problem?
the word problem. So real quick, I'm going to help you draw your table for the word problem on your homework. I'm not going to give you the answer, but I am going to help you draw the table. Okay, so I'm going to help you get your table drawn.
Was there a specific way to do that problem?
Okay? Some of you might be able to do it. Some of you are going to need some help, so that's what I'm here for. I'm going to help you with your word problem on the table, okay? Let me make this less blurry. Okay, if you turn to page 100 in your book.
120.
No, just...
Where's the table for problem solving?
Yes. Okay? If you turn to page 100 in your book, you can see on the problem, it says, Caden is 12,000 feet from his home. Or 1,200, sorry. 1,200 feet from his home.
12 steps.
He walks 200 feet toward his home each minute. How many feet from his home is Caden after walking for 4 minutes? Explain how you found your answer. So there are 2 steps to this. This is a 2-step problem. First, we need to draw ourselves a table.
He only has 1,000 to go.
How many minutes are we trying to figure out here?
No, it's not minutes. It's feet.
No. How many minutes does he walk for? It tells us how many minutes.
4.
It wants to know how much he has left after 4 minutes. So we need to make sure we have 4 spots on our table. Okay? Our input is going to be the number of minutes. And our output is going to be the number of what? Number of feet, right? Input is going to be the number of minutes. Output is going to be the number of feet. Okay, so looking at this, we know how many feet he walks in 1 minute, right? It tells us. How many feet does he walk in 1 minute? Henry?
200.
200 feet in 1 minute. So, what's my rule here going to be?
Multiply by 200?
Indeed, it is going to be multiply by 200. Now, here's the part you need to know. Our minutes are going to go up by 1 here, right? Okay. When you get to this number, though, is this number your answer?
No.
No. This number tells you how far he's walked in 4 minutes. But that's not what the question is asking. The question wants to know how many feet from his home is he? How much farther does he have to go? So, how far away was he from his house when he started?
1,200.
1,200 feet, right? So, when we get to this number, and I'm going to tell you right now, it's not 1,200. What do we need to do with that number once we get it?
Subtract.
We need to subtract it. So whatever number you get here, you need to place it into the subtraction problem and subtract. And that will be your answer with feet on the end. You'll put feet on it, okay? So you need to finish filling out the table, but this number is not your answer. This number you then need to subtract. Does that make sense to everybody? I will leave that on the board for you for a second. Okay? And let me tell you what your homework is real quick. Your homework is going to be page 99 to 100 all.
Even the right about it?
Even the right about it, because the right about it, it's just telling you everything you need to know to make an input-output table. Okay?
But does it count because we did our work on our graph paper? Yeah.
That's fine.
So we don't have to explain it?
That's fine. Yeah, if you do it in your graph paper notebook, that's okay. Alright? Alright, so your homework is 7-5, pages 99 through 100, all, okay?
No extra credit.
No extra credit on this one, okay? No extra credit on this one. I know, that doesn't happen very often. It did this time, every once in a while, okay? You have a little bit of time to work now. Chapel is in about 10-ish minutes, which is not enough time as I would like to give you, so I will try and find some time this afternoon for you to work a little bit longer on this. Yes, okay? So you got about, we'll probably clean this up in about 8-ish minutes, okay? 7-ish minutes, but I will give you more time this afternoon to work, got it? Alright, go ahead and get to work.